So we're gonna continue where we left off on page 33. Today is actually a fairly decent, quick-ish day. 33. Decent-ish, quick-ish day. Not too much thinking. What? The word of the day or Wordle? Well, yeah, everybody knows Wordle.
No, I said you know what the word of the day is though.
For Wordle?
Yeah.
Yeah.
What is it?
Can't tell you, that's cheating.
Well,
All right, anyway,
that's fine.
we are still going to be talking about humidity. We're going to just continue humidity. Those of you, did anybody have Mr. Miga already? So we're doing what you did in Mr. Miga's class. So those of you who already had Mr. Miga, you're going to sail through this stuff. My class, I decided to hold off because why teach it twice when I could just teach it to you now, and then we'll do it in lab starting Monday. So again, we were doing relative humidity, which is how much water's in the air compared to how much water the air could hold. We talked about yesterday, if the air is saturated, just like if a sponge is saturated, what does that mean? The air is completely full of water. It's holding as much water as it possibly can. And just like a sponge that's holding as much water as it can, that means it's 100% full. We also talked about that warm air can hold more moisture than cold air. And that is because, I had lost my picture of it, but if we had some warm air, all right, let's start with cold air actually. Cold air, the molecules are jammed in pretty freaking tightly. Because remember, cold molecules cuddle so that they can warm up. When we have cold molecules, there's not much room for water. So I'm only able to fit a few droplets of water in between those spaces. Whereas if it is warm air, what do the molecules do when they're warm? They spread out, just like hot, sweaty humans. Hot, sweaty molecules spread out, leaving quite a bit of room for water to fill in the spaces. So warm air can hold more water than cold air. We always demonstrate this right here. Warm air, because it spreads out, can hold a lot of water. Cold air is unable to hold as much water. Another way of thinking about this is the cold air is going to fill up with water. It's not going to take as much water to fill it up. Whereas the warm air, it's going to take quite a bit of water to fill it up. This actually describes why you're so uncomfortable in the summer when the air is near 100% humidity. The cold air could be 100% humidity, and it's really not that much water. But with the warm air, when it's near 100%, it's a lot of water in the air, making you feel very uncomfortable. All right, speaking of, so we did the warm air can hold more water. We're going to skip that diagram for now. And then we got to naming these two different instruments. We are going to use these instruments not only to determine relative humidity, but at the bottom, dew point temperature. So we do need to get the notes for dew point temperature. Dew point, you guys know what dew is, right? Okay, condensation in regular everyday people words. What is dew? When you wake up in the morning and the grass is wet, that's dew. It actually isn't only in the morning. When else do we get dew? At night. What's similar about morning and night compared to the regular rest of the day? It's usually colder. Dew point temperature is the temperature at which water comes out of the air. So we're right on the bottom of page 33. So in other words, it's the temperature at which the air is saturated or 100% humidity. So dew forms when the water temperature drops to the dew point and the air becomes saturated. So for dew to form, I'd like you to imagine during the day, nice and warm, so we have warm air. So we have this jug of warm air during the day. Warm air can hold a lot of water. So even if this guy wasn't even filled all the way up, so it doesn't have to be, it's not 100% during the day, because during the day, does water droplets form on the grass usually? No, it's a morning and night thing. So during the day, the air is not 100%. So this bucket is not full. But then what happens in the evening? We already said it. What happens in the evening compared to the day? Gets colder. So the air switches to this little container. So I have to go from the water that was in this big container to the water that would fit in here. If I was to dump, even if this guy was half full, and I dumped it into this cold container, what's going to happen? It's going to overflow. And that overflow is the dew on the grass, because warm air can hold a lot of water. But if you change the temperature to cold, it can't hold as much. So whatever was in this big warm air doesn't fit in the cold air. So it drops it out, overflows it, and that's the dew on the grass. This is similar to when else do we have water that just comes out of the air? Like you find water droplets and it wasn't raining, or your cup isn't leaking. Where else do we find water droplets? Come on, guys.
Say you left like something cold outside and then it's warm out.
Doesn't even have to be outside, right? Have you ever had a sweaty water bottle?
Yeah.
And I say sweaty, is it really sweat? No. So mine, I don't drink cold water, but imagine if this was cold, ice cold water. I drink room temperature water. It's what you can't drink a gallon of cold water. It just isn't gonna go well. So sweaty water bottle, sweaty pop can, all sorts of things that get sweaty. Like even in the summer, can you think of some other things that get sweaty in the summer besides us? Not that kind of sweat. What? Yeah, so a pop can or a pop bottle, they will definitely get sweaty. Do your toilets sweat? Mine does. Yeah, it does, because toilets are filled with really cold water and your bathroom is really warm, moist water, or really warm air usually. Good. Another time that you might notice water droplets coming out of the air. Can you think of some other things?
Rain.
Okay, besides rain. We're talking about water just coming out of the air. You don't even have to leave your window open overnight. You ever get into a school bus and sit next to the window? What happens to the window? Fogs up. How about if you breathe on glasses, or those of you with the masks on with glasses? Why do glasses fog up? How does glass typically feel to the touch? It's a little cooler. Glass is typically cooler, same in the cars. Then you put hot, moist breath on them. Here's what happens. You've got warm air floating around and boom, it touches something cold. Now that air can only hold this much water. So what has to happen? The water droplets come out of the air in the form of the fog on the glasses or the fog or the sweat on the water bottles. So again, we got warm air, which is holding a whole bunch of water. Boom, it touches something cold. So now the air is cold and it can only hold this much, which is a lot less. So it drops off its water. And that's how you get sweaty pop cans or sweaty water bottles, any of that stuff. So it just drops it to its dew point temperature. We then talked about, did we on the next page talk about a wet sock or a wet bulb versus a dry bulb? We did? Okay, so you weren't here, were you? So you watched the video, it wasn't this class, I don't think. Did this class get to wet and dry bulbs on the next page? We did, okay, perfect. So I couldn't remember because I did not get that far with all my classes. So we have our sling psychrometers, which we talked about yesterday, which are nothing more than 2 thermometers. One's wearing a sock that we get wet. So if you don't already have these at the top of page 34, add these in. A dry bulb, so when I swing this around, the dry bulb's just going to measure the temperature of the air, just whatever the normal air is. But the wet one is going to cool off. Again, it doesn't cool off just because it has water on it. It cools off because that water evaporates. So you sweat, and I talked about this yesterday. You all know you sweat because it's your body's way of cooling you off, right? But what we talked about yesterday is you had never known why sweating cools you off. And sweating cools you off because the water will evaporate off your skin, and that process takes energy away. So energy in the form of heat, and it cools you off. So the same thing's going to happen here. When I spin this around, the wet one's going to get colder. So just to reiterate, guys, which one's going to be colder?
What?
The wet one. There's no time that the wet one could ever be warmer. So by the way, if you're in lab and your wet one is warmer than your dry one, probably what happened is your thermometers are busted. So there's a couple of things that could happen. One, they legit just break in half because somebody dropped them and they broke. The other thing, and I don't know if I have any examples of this. The other thing is I think I fixed most of them, at least mine. But the other thing is these cost about 20 cents each. And if you notice, the glass is literally held on with a staple. So the glass, when you do this, could sometimes fling off. So if you get a wet bulb that's ever warmer than your dry bulb, something's screwed up. Now, how about this? Could the wet bulb ever be the same as the dry bulb?
Yeah.
Yeah, the wet bulb could be the same. So what's not happening if the wet bulb is the same as the dry bulb? What? Okay, so it's the same temperature, so it's not getting cooled, so it's not evaporating. If the water's not evaporating, what does that mean? Yeah, why? So what's that mean, that the water can't evaporate?
Full. Like air.
It's not full?
No, it is.
It is full. If water can't evaporate, think about it. Guys, can water evaporate while it's raining? No. There's no room. The air is all filled up with water, and water cannot evaporate when there's 100% humidity. If that sponge is full, you can't suck any more back up into it. So they could be the same temperature, but the wet bulb will never be warmer than the dry bulb. So let's practice this. I think, did we start practicing this in this class? Those of you who had lab with Mr. Miga or Mr. D already, this stuff should be reviewed to you. So you guys are going to ace today. The rest of you, it's not hard. You just have to learn it first. So we're going to go right to example 1. We're still on page 34. We're going to use page 12 in our reference table. So if you haven't gotten that out already, please grab your reference table. Page 12. And everyone's going to need their own in front of them. You will not be able to see mine up at the board for this. It's too far away. I am positive. Somebody else in the page. So example 1's on the board. It says, so here's the thing, you're either going to need to find the dry bulb. So like in lab, you had to find the wet bulb and the dry bulb yourself. Or just like other like pen and paper tests, it'll be like this. I'll say, hey kid, the dry bulb temperature is 20 and the wet bulb temperature is 15. Find the dew point temperature and the relative humidity. So we have to go through this process, and we're going to use page 12 of our reference table. So I think I started talking about this. Do you guys remember multiplication charts? So remember, if you think about them, if you wanted to do 3 times 4, you found a 3 on one side, you found the 4 on the other, and you brought your fingers together, and magically 12 was there. You could have done it the other way for multiplication. You could have done 4 on this side and 3 on the top and brought your finger together, and it still says 12. Here, these numbers are not interchangeable. So to do this, if you notice, everybody look at your reference table. So anyone who's starting, please stop and look at your reference table. In fact, I think I'm going to do it up here so we can see it together. Take a look. So first of all, there's two charts here on page 12. There's a dew point chart and a relative humidity chart. How do they look? They practically look the same. What's different about them? Yep, so the actual number. So first of all, this one's given in Celsius. This one's given in percent. That's the first difference. What's another difference? Take a look, guys. This is not something you had to know. Look at the charts. They both have some negatives. Oh, you mean as the answers? Yeah, that's what I'm getting at is the answers are different, meaning the stuff in the middle. So the dew point has very different numbers than the relative humidity. So just like all earth science, you need to read all the words and be careful. If they ask for dew point, use the dew point chart. If they ask for relative humidity, use the relative humidity chart. They are not interchangeable. And you know what? I guarantee you if it's a multiple choice question, if they want the relative humidity, they will give the right answer for dew point as well and expect somebody to screw up. That's the kind of meanness things they'll do. So make sure you read all the words. All right, now that we figured that out, besides that, both charts work the same way. So I said with multiplication charts, it didn't matter which number you had on the side and which number you had on the top. They both worked the same. Here it's different. Let's look at the side. What is the side labeled? No, not Justin. The rest of you have eyeballs too. Not Jake, not, you guys all have eyeballs. How about you, Calvin? What's the side numbers labeled? Yeah, they're the dry bulb temperature. So the dry bulb for both charts, so the actual room temperature, is going to be the number that you use on the side. So whatever the actual temperature is. Now everybody look at the top label. Nate, what is the top set of numbers for? The difference. Everybody grab your pen and circle the word difference on both of them. So what does difference mean? Subtract. This does not say wet bulb temperature. Do not screw up and do dry bulb and wet bulb and bring your finger together. It's dry bulb and difference and bring your fingers together. So difference means subtract. Don't make that mistake again. I guarantee you the Regents will give you that wrong answer as an answer on the multiple choice test. So let's give this a whirl. Example 1, determine the dew point first. Now I worked this out really simple. You don't always have to show your work, but for these two problems, let's do it. According to the reading in the question, what is the dry bulb temperature? 20. And again, that was right here. The dry bulb temperature is 20. What's the wet bulb temperature? 15. So I know 20 minus 15 is pretty easy, but if you don't trust your math skills, use a calculator. Use your fingers. Please do not screw this up because you subtract wrong. That will suck. So what's the difference? 5. So we grab our reference table. Again, we're looking for the dew point. So that's the top chart. What again was the dry bulb? 20. So you point to 20. What's the difference? 5. So you point to 5. You bring your fingers together. What do you get? I got 12. Did everybody else get 12? Okay, so that's the dew point. By the way, these are 12 degrees Celsius. You should always label your final answer. If they expect you to label it and you labeled it with a percent, I would have to mark it wrong. Already? That's quick. Thanks, Aiden. All right, do the relative humidity. You got this one, do that one on your own. Yeah.
An army speaker? What's that?
Try again. 5.
Oh, yeah. I just heard that.
It sounds more, I did it.
What did
I
you
did
do?
40
What?
push-ups.
Okay, why are you touching this? And you just seriously just broke it.
That's
Yes,
the-
you did. You seriously had this. It wasn't like this. So if you did not get 58, you're gonna have to, and what are the labels? 58 what? Percents. If you did not get 58, you're gonna need some help on that one. Go ahead and do example 2 for the dew point and relative humidity.
Wait, what do you have to do?
Yes.
All right, so again, I saw some very common mistakes. Again, the top number. I had you circle the word difference for a reason. Because if you try to do the wet bulb temperature, you're gonna get the wrong answer. So if you did 14 and 9 and got an answer of -10, you used the wet bulb. You have to do 14 and 5, the difference, and you got 4 for the dew point. The other mistake that I was seeing, and this is common too, I am not joking, you really should use your fingers. Our eyeballs with these, there's a lot of numbers. So what I'm saying is when you're doing 14 and 4, Legit, bring your fingers down and over. Whoops, see, I even screwed up because it's 5. 5 and 14, bring your fingers together and point to the number. If you try to just eyeball it, you'll probably end up traveling down a little ways or off to the side the wrong way. You're also, if you want to, especially if you're using pencil, but even if you're not, if you want to actually write on these, and you did 5 and 20, oh, that was the last one, 5 and 20. What was it? 14 and 5. You could do that too. Write on, if you write on them and they're so messy, you need a new one, I'll get you a new one. I'm not worried about it. I'll still give you extra credit, don't worry. Okay. So not so bad, right? Homework's page 35, which is a lot, right? Oh my, but I'm done talking. Well, I'm almost done talking. I want to do a few of these together. So we're doing nothing else but your homework for the rest of the period. So you'll get at least halfway through the homework, probably more, and then just have to finish it up for homework. First thing I want to make sure, is everybody paying attention for a second? I'm going to be giving you some answers. So if you're not paying attention, I am not helping you again. That's first thing. You need to pay attention now. The second thing is, see that 8? And I know mine's kind of blurry. So we're about a little less than halfway down. Do you see that that's a -8? So that's a -8 and a -18 with it. So if you don't see those negatives, make them darker so you see them. Yep, follow it over. Dew point temperature is -18. So the -8 and the -18 are in the same line. Same with at the very bottom. That's a -9 and a -10. Hey, quick question. When you subtract a negative, if I do -9 minus -10, do you remember how to do that? You add a positive. Please don't let subtracting negatives be the reason you get this wrong either. So what is -9 minus -10? No, it's not. You just told me -9 minus -10. You add a positive. That equals 1. So the difference between -9 and -10 is 1. So these first few are pretty easy. Dry bulb, wet bulb, fill in the difference, fill in the dew point, fill in the relative humidity. But then it gets weird. The third one down, let's do this. The one that starts with 4, the third one down. 4 is the dry bulb. They don't give me the wet bulb, but they tell me the difference is 4. So the difference between the wet bulb and the dry bulb is 4. What do I do? 4 plus 4, so the answer could be 8. Yeah, because 8 minus 4 is 4. Is that the answer? So you're saying 8? So let's talk about 8. Is the difference between 8 and 4?
Oh, yeah.
But is the difference between 8 and 4 4? Yeah. But what's the problem with 8? So why if it's bigger than 4? No, okay. So yes, I see what you're saying, but you're right. So that's not it. The difference between 8 and 4 is 4. But what is wrong with saying the wet bulb is 8?
It can't be higher than.
Wet bulb, did you say that? Yeah. Yeah. Talk louder. Because the wet bulb can never be warmer than the dry bulb. It could be the same, but it can never be warmer. The wet bulb can never have a higher temperature. So while the math could work out, this is not true. So if you wrote 8 there, cross it off. So 4 minus what gives you 4? 4 minus 0 works. So you do always, so in case it is always dry minus wet. So to fill in these wet bulbs, you can always go like the next one, 10 minus what gives you 3? 10 minus 7. So it's always you don't have to do like algebra. It's, I mean, it's algebra technically, but it's like 3rd grade algebra. Just take the 10 minus what gave you 3. All right, how about the next one? This 26 one. I give you the dry bulb, but I don't give you the wet bulb or the difference. So how do I find any of those? So I do give you the dew. Okay, hang on, we're not there. So you got to work with, when the stuff's not there, you got to work with what I give you. So I gave you 26 and a dew point temperature of 6. So which chart should I even be beginning with? Why did you pick dew point? Because that's what I had. You work with what you had. So now I go with what they gave me. They gave me a dew point of, or I'm sorry, a dry bulb of 26, right? Here is the dry bulb of 26. Is that what they gave me? I can't remember. 26 and then a dew point of 6. How can I find any of the other numbers? Go over, say find the 26, go over till you get to 6. Now what do I know? Now I know the difference is 11. So I can fill in the difference. I can fill in the difference now. So 26 with a difference of 11. 26 minus what gives you 11? 6 minus 15 gives you 11. Now you know how to, yeah. Huh? Did I?
No, that's right.
No. So I went to, so again, let me clear this up in case we're confused. So I went to 26. And they tell me that when the dry bulb temperature is 26, they told me the dew point was 6, which is right here. And now I go up, and that's 11. Should we do another difficult one together? I don't want to do the next one. That's an easy one. That's because it's negatives. You guys, I'm going to leave you trying to subtract some negatives there for a second. But I want to go down to this one that's 17. Okay, that'll do it. Down to the one that's 17. So we're almost at the bottom. See it? Seems pretty easy. 17, dry bulb of 17, wet bulb of 13. What's the difference? 4. So go find the answer. What's the dew point? What's the relative humidity? There's no odd numbers. So we do go in between. So here's what I mean. Again, dry bulb of 17 is not there. Okay, so this would be 17 right here. And what did they say? What is our difference? 4 was that? So then we go to 4. That's there. Now I know what 16 is. I know what 18 is. So then what must 17 be? 10. So you do just sometimes with the odd numbers have to estimate. How about, I'll let you keep going. So that's it. Neil, you guys only have 5 minutes. How about I shorten this up and you only have to do the chart? Good with that? Okay, page 35, chart only.
Get it on. Get it on.
What's wrong with you over here? You're thinking a lot. Is there anything I can help you think?